Okay, so we're going to run a little experiment. I would do this in class with you guys if you were here, but we're going to run some emission spectra. So the first tube I have in here is helium. Helium is a clear gas, but once we run an electrical current through it, it is going to begin to glow as a plasma. So electrons are jumping up in their orbitals as they get energy, and then they are going to begin to drop back down again and release that light that they had absorbed, that energy they had absorbed as light. It looks kind of a peach to yellowish color, but let's take a look by putting this light through a prism. So I'm putting this prism over the light, and one thing you'll notice on this are the colors that are coming off of that prism. So as I put this prism there, you're going to notice there's a little bit of red, a little bit of yellow, quite a bit of yellow, and then there's a teal and a little bit of purplish colors. So that is the actual spectrum of light that is coming from the helium plasma. And all of it together is combining to form this kind of peach color. So I'm going to try a different gas. Let's try the third most common gas in the Earth's atmosphere, which is argon. So argon represents about 1% of the Earth's atmosphere. It's third after nitrogen and oxygen. It's a clear gas, but in a plasma state, it glows kind of a lavender to purplish color. Now that's what it looks like to our naked eye, but if we were to run this through a prism, you can see the bands of color that are coming off of it. You can see definitely like a bluish purple, and then some greens and some reds. So those are the spectral lines that combine, so if you run those spectral lines through a computer, it'll be able to identify, oh, this is argon. Let's try hydrogen, the most common gas in the universe. The 90% of the sun is made of hydrogen. It is the most common gas of the universe. It also kind of glows a bit of a purple color, but it's going to have a different band pattern than argon did. And as you look on here, you're going to see, look at how much red is located in this, as well as a big band of teal. So you're going to get a different banding pattern, so even if it superficially looks similar, you'd be able to tell that this is a different element. Next, let's look at mercury. I mentioned mercury earlier as being an element that we use in our fluorescent lights, but I also mentioned that a lot of the light is released in the ultraviolet, which we can't see with our naked eye. So mercury vapor produces this kind of bluish light. A lot of the light coming off of it is ultraviolet, which means if I put my arm here, I can get myself a little suntan. Let's take a look at the bands of color that come off of mercury, and you can see on here its distinctive banding pattern. There's actually quite a bit of green and a little bit of yellow coming off of the mercury. So lower this a little bit and see, oh wait, if I go a little further, there's a little bit more of these ultraviolet to purplish colors off to the side down here. So that is the banding pattern for mercury. Okay, let's do one more gas for this session, and we are going to do neon. So you've all probably seen neon lights before. Well, we're going to see a neon light now. So neon is a clear gas when not as a plasma, but when you turn it as a plasma, it comes out as a very bright reddish orange. So neon is used for a lot of purposes, for signs and stuff like that. And as we run this prism past the neon, let's see if I can, there we go. You'll actually see there's quite a few bands with neon. You're going to see a little bit of green, a little bit of blue, a little bit of purple, but definitely there's going to be mostly red. If I can, this camera is having a hard time. It's making it look much yellower than red. And let's see if I can see what happens if I turn the light on. That doesn't really help. So the camera is having a hard time. It looks a lot redder to my eyes than it does to this camera. But nonetheless, you can see the banding patterns that are located there.